Okay, these are sample problems over section 7.3, which is a power raised to a power. Notice in this first problem we have one base, which is n, and it's raised to two exponents, 8 and 4. The previous problems, each one of these exponents would have had their own base, and we would have added. But in these problems, because we have one base raised to two powers, we're going to multiply instead of adding. So 8 times 4 is 32, so our answer would be n to the 32. This one would be c squared times 1/4. Remember, 2 times 1/4, you would multiply 2 times 1. So you would have c to the 2/4, which simplifies to c to the 1/2. The next one, you have x to the 2/5 times 10. You would multiply the 2 and the 10, so that would give you x to the 20 over 5, and 20 divided by 5 is 4, so your answer would be x to the 4th. Okay, don't forget that this d has an exponent of 1. It's outside of the parentheses, so it's not going to be part of this expression right here. So we're going to have d to the first, we're just going to bring that over, times d to the -2 times a -9, which would give us d to the first times a -2 times a -9 would be a positive 18. And now the exponent of 1 has its own base, and the exponent of 18 has its own base. So now we will add the 1 and the 18 to give us d to the 19. So this is a good problem to study so that you know when to add and when to multiply exponents. In this next problem, we have t to the second times a -2. And then we have t to the 2 times a -5. So t to the 2 times -2 would be t to the -4, times t to the 2 times -5 would be t to the -10. And now they each have their own base, so we add. T to the -4 plus -10 would give us t to the -14, which is equal to 1 over t to the positive 14. This is another good problem to study and make sure you know how to work. Okay, in this problem we have m to the third to the -1, so that would give us m to the 3 times -1 times x to the 1/3 times 1/4. So we have m to the -3, 1/3 times 1/4, you multiply the ones in the numerator and then you multiply the denominators, so that would give us 1 over 12. Rewriting this without any negative exponents, we would have x to the 1/12 divided by m to the third. Remember, I told you in class that it's a good idea to rewrite these expressions so that everything in the parentheses has an exponent on it. And now you'll remember that you have to distribute this -2 to every exponent that's inside the parentheses. So that would give you 7 to the 1 times -2 times a to the 1 times -2, which equals 7 to the -2, a to the -2, which simplifies to 1 over 7 squared a squared, or you could write that as 1 over 49 a squared. Either one of these answers is okay. 7 squared is 7 times 7, which is where the 49 came from. I don't care which way you leave your answer. Okay, in this one we have y squared z to the -3, both of those raised to the 1/6. So we'll have y to the 2 times 1/6 times z to the -3 times 1/6. And then we have our y to the third times 2. So multiplying all this out, y to the 2 times 1/6 would be 2 times 1, which is y to the 2 over 6, times z to the -3 over 6, times y to the 6th. Simplifying our fractions, 2 over 6 is the same as 1/3. A -3/6 would be the same as a -1/2, and then y to the 6th. So we have a y to the 1/3 that would stay in the numerator. Our y to the 6th will stay in the numerator, and our z to the 1/2 will go to the denominator. Our y's have the same base, so we do y to the 1/3 plus 6 divided by z to the 1/2. Remember, to add fractions, we have to have the same denominator, so this would be y to the 1/3 plus 18 over 3, because 18 over 3 is the same as 6. And so adding these, we would get y to the 19 over 3 divided by z to the 1/2. And while it's not very pretty, that would be our answer. Okay, remember the 2 has a 1 on it, so we have 2 to the 1 times -5, j to the 2 times -5, k to the 4 times -5, times our next set of parentheses, k to the -1 times 6, j to the 7 times 6. So let's multiply all of this out. We would have 2 to the -5, j to the -10, k to the -20, k to the -6, j to the 42nd. So we would have 2 to the -5. On our j's, we have a -10 and a 42, so we would add those. On our k's, we have a -20 and a -6, so we would add those. And since I'm running out of room, I'm going to go ahead and simplify this as I work it out. So the 2 to the -5th would go in the denominator. A -10 plus 42 is a positive 32, so that would stay in the numerator. And a -20 plus a -6 would give us a -26, so that would go to the denominator and become positive. And that would be our answer. Okay, one last problem. Once again, remember this is 3 to the 1st, so we would have 3 to the 1 times 2 into the -6 times 2, which would give us 3 squared n to the -12, which is equal to 3 squared over n to the 12th. You could stop there. Or 3 times 3 is 9, which would give you 9 over n to the 12th. Either one of those answers is okay.